So I just want to finish this lecture by showing you the calculator that I've input into the web page to help deal with partial derivatives. So the syntax for calculating a partial derivative in Sage is you take your function and then you write .diff of the variable, and so whichever variable you're interested in, and that will produce the partial derivative of f with respect to that variable. So I've set up a calculator here that should help you with this process. So the idea is that in Sage you have to start by initializing your variables. So here I'm using variables x, y, and z, and then I'm defining a function in terms of those variables. This is x squared times y plus y squared times cosine of x, y, z. So if I click evaluate here, let's just look at the output. So what the output tells me is that the partial derivatives of the function that I input with respect to the variables x, y, and z are given by the three coordinates of this vector here. So this is saying that the partial derivative of this function f with respect to x is this first expression, negative y cubed times z times sine of xyz plus 2 times xy. Then the partial derivative of f with respect to y is this second coordinate, and the partial derivative of f with respect to the third variable z is this third coordinate. So when you're working on your homework, you should be able to use this to check your work. Now, I want to point out that you have a lot of freedom here. This code allows for a lot of freedom. So if you wanted to change variables to like r, s, t, and w, you could take your expression for f and properly define it in terms of those variables. So let's say I was studying r cubed times exp of s plus t squared plus log of t times w minus cosine of t squared minus 4 or 3 times w to the fourth. So that's a complicated expression involving r, s, t, and w. Assuming I wrote this code correctly, when I click evaluate, it should update. So yeah, so now I have my f, which is defined in terms of r, s, t, and w. That's the expression I just typed in. And what this is giving me are the partial derivatives with respect to these 4 input variables in this order. So with respect to r, my partial derivative of this expression is equal to this first coordinate, 3r squared times e to the t squared plus s. With respect to s, I get the second coordinate, r cubed times e to the t squared plus s. With respect to t, I get this third coordinate, and with respect to w, I get this fourth coordinate. So this code has flexibility built into it, so whatever scalar field you're studying, you can start by initializing your variables and then defining your scalar field as f, and when you click evaluate, all the partials should print out so you can easily check your work. So I hope this helps.